We're ready to talk about the remaining portion of section 8.1. This material will be on your fourth module test. We had talked about law of sines previously, and we saw how to use the law of sines to help us solve a triangle that had two angles known and one side known. All right. Here we're going to talk about how to find how to solve a triangle when you've only got one angle and you're given the lengths of two sides. This side-side angle triangle situation is what we call the ambiguous case. That means that depending on this second side length over here, so I've drawn a line segment AC. So here's point A, here's point C. Depending on, so this side over here, depending on this side, we may have one triangle, we may have two triangles, or we may have no triangles. So what we have to go on is we're given this side length A, this angle A, we're given this side length, which we call B, and we are given a side length over here, but we're not told what the angle is on it. So there's several scenarios that can happen. So I'm going to take a toothpick and I'm going to use it to try to show different scenarios that can happen here. All right. First, I'm going to extend this bottom line out because my triangle could come over here. I just don't know yet. I don't know where point B needs to fall yet. I will be given information about side A over here. What are some different scenarios that can happen? Well, let's just talk about this. This is not a side length that's given, but it is an important measurement. This is the height. And the height, of course, forms a 90-degree angle. Okay, so what happens if if this side over here is the same length as H? So if side A over here is the same length as H, so if I take my toothpick and put it on here, so that's, if I put my thumb there, so that would be the length of the height. If it comes over here like this, so we want to look at what would happen if we were to rotate it as far as we can in either direction, all the way back this way and all the way back this way. Looking at the length of my toothpick, I can see that I would have one triangle when it's drawn just like this, given the 90-degree angle. So if this side over here, opposite angle A, so if side length A is equal to the height of the triangle, then we will have one triangle. Okay. What if it's shorter than, well, what if it's longer than the height? So what if this side, opposite angle A, is longer than the height? So let's say it's like this. Okay, so now it's longer than the height. As we rotate this through, when does it touch? So we would call this side C over here, even though we don't know how big it's going to be, because that was angle C at the top, so this is side C. So going from angle C at the top, our side length is longer than our height. Okay, if you look at what happens as you go through here, okay, you can see some possibilities that start to happen. This is one possibility. If your side length is longer than your height, then you could have a triangle formed here. Okay, or if you rotate it back this way, you can see you don't have a triangle here because that side length is too long. But when you get over here, you've got a second triangle. And I'm sorry, my finger's on the way. So so if your side length is longer than your height, you can have two triangles, one here and one here. Okay, so we can have two triangles if side A is longer than the height. Now, is it possible for side A to be longer than the height and another situation happen? Well, what if we did it like this? So now I've got it so that my side length A, this is my side length A. I want to see what happens if it's longer than side length B. Okay, if I did it like that, if I rotated it all the way back here, if I rotate it all the way back like that, that creates a triangle. Okay, can I get a second triangle if my side A is longer than side B? Well, if I rotate it back this way, If side A is longer than side B, then you're not going to be able to create a second triangle from it. And that's what's happening here. So my side A is longer than side B, so when that happens, I've only got one triangle that's formed like this. Okay, so if A is greater than height, and also A is less than side length B, I get two triangles. If side length A is greater than side length B, then that's only going to give me one triangle. Okay? What else can happen? So we saw what happened if side length A was equal to our height, like this. That gave us one triangle. If side length A was greater than our height, we could get two triangles as long as side length A was shorter than side length B. Because if side length A is longer than side length B, you'll never be able to get a third triangle out, or a second triangle out of it, because it will never touch the line at the bottom. Okay. If side length A is greater than side length B, we get one triangle. Okay. What if side length A is shorter than the height? So let's look at it here. Let's say this is my height, but side length A is like this. If side length A is shorter than my height, what happens? Side length A is less than the height. Is there any place I can rotate this to give me a triangle ever? It's impossible this time. If side length A is shorter than my height, then I'm not going to get any triangles. I'm not going to get any triangles at all. So if A is less than height, we have 0 triangles. Okay. Now, what we're going to do is we're going to work some examples of these types of problems. We have to determine what situation we have, and I'm going to show you how that can be done. Okay, so we're going to do 3 examples of side-side angle problems where we're asked to solve the triangle if possible. So we're going to see a scenario. We're going to see one of each of 3 of the scenarios, whether we've got 2 triangles, 1 triangle, or no triangles. In my first example, we have angle A is 35 degrees, B equals 8, and A equals 6. This is angle A. We've got angle C here, and then angle B is, even though we don't know if we have a triangle, I've drawn it anyway just so that we can put all of our information in and try to solve for the remaining pieces. So angle A is 35 degrees. Side B has length 8. Side A has length 6. Okay, and we're going to try to solve for angle B, side C, angle C. So we're going to start by using law of sines to solve for angle B. So by law of sines, I know that I can do 6 over 35 degrees. So that would be A over sine A. 6 over sine 35 equals B over sine B. So 8 over sine B. Okay. I can cross multiply, and I'll have 6 times sine B equals 8 times sine 35. And then I can divide both sides by 6. So sine B equals, so sine B equals 8 sine 35 all over 6. And then we take the inverse of this. So when we take the inverse, we're going to do, I'm going to type in 8 times sine 35 all over 6 first. So 8 times sine 35, enter, then divide by 6. Then I'm going to go second, sine inverse, second answer. That's giving me 49.886, which I can round, I'm just going to round to 50. So I'm getting B equals 50 degrees. Okay? Now, because we did the sine inverse function, remember that your sine values in quadrants 1 and 2 are going to be the same. So for example, if you're over here, sine of 30 is 1/2, also sine of 150 is going to give us 1/2. So when we do sine inverse, that means that we need to find the other angle that goes along with the answer that we got. We got an answer of 50 degrees. So we know that there's a reference angle. So we found 50 degrees, which would be around here. We know that there's a reference angle on the other side over here that's going to give us the same sine value. So to find it, we can do this. We can just subtract from 180, or get the supplement. Excuse me, the complement. Get the complement. The supplement. That's right, supplement. So we're going to do 180 degrees minus the answer that we got. So the supplement of 50 degrees is going to give me 130 degrees. So we're getting two possible values for angle B. So we found, I'm going to call this B1, and then I'm going to make a column for B2, which will be 130, which is a supplement. Okay, so looks like we've got two possibilities here. Both of them have angle A 35 degrees. Okay, so we can set it up as two columns. And then let's find angle C for our first potential triangle. So to find angle C, that's easy. Just do 180 minus 35 minus 50. So angle C for the first triangle would give us 95 degrees. And in our second triangle, we're going to take 180 degrees minus 35 minus 130. And that gives us 15 degrees for C2. So it looks like we've got two complete triangles in this scenario. If you were to draw these triangles, you would find that one of them is going to look very similar to the picture we have up here. And if you remember the illustration we did earlier with the toothpick, if you can envision taking it like this and going back this way, you would get a triangle that looks similar to this, where it's going to have an obtuse angle. So if you wanted to draw it, your second triangle, like you have over here, would look something like this. And then this one over here is going to look like the one that we've got pictured, like that. So the only thing left now would be to find side C for the first triangle and side C for the second triangle, and we'll go back to use our law of sines a second time to get this one. So in triangle 1, angle C is 95 degrees, so we'll do side C over sine of 95 equals, and then we could do side 6 over sine of 35 degrees. Cross multiply. Divide by sine of 35. Be careful typing this into the calculator. You want to multiply across the top, hit enter before you divide. So we've got 6 times sine 95, enter, and then divide by sine 35. And that gives us 10.4 for side C in the first triangle. So little c1 is going to be 10.4 for the length. So these are the measures for triangle 1. And do the same thing for triangle 2. So side C over the sine of, our angle C is 15 equals, and then you can go back and do side 6 over sine of 35 degrees. Cross multiply. Divide by sine of 35. Okay, what does that give us? That gives us 2.7 for C. Okay, so little c2 would be 2.7 for the side length. So that's the scenario where you have two triangles, and that's how you would go about solving that one. We're going to be able to use the same techniques for all three cases, so that is helpful. You don't have to use completely different methods for each scenario. So in our second example, let's look at example 2. Example 2, we're given angle A is 45 degrees, side B is 5, and side A is 3. So I'm just going to draw my triangle again. I'm just going to assume it's got this shape just so I can get my information in there to look at it. So there's 45 degrees for angle A. Side B is length 5. Side A is length 3. Okay? And we can use law of sines to get angle B. So we'll do 5 over sine B equals 3 over sine 45. And we can cross multiply, so 5 times sine 45 equals 3 times sine B. Divide both sides by 3. Okay, so I'm going to type in, and I'm going to be using my inverse function, sine inverse, but before I do that, I'm going to type 5 times sine 45, enter, divide by 3, then I'm going to, and that's giving me 1.1785, then I'm going to go second sine, for sine inverse, second answer, and enter. Okay, so when you type this into the calculator, I hope you can see, there you go, hopefully you can see that. You'll see how I'm getting error domain. Okay, that means that there's an issue with my domain. What did we get when we typed in 5 times sine 45 divided by 3? That gave us 1.1 or 1.18. Okay, so we were trying to determine the sine of what value would give me 1.18. So we were doing 1.18 equals sine of B. So sine of what angle would be 1.18? Well, if you recall, the domain of your sine function is going to be, the range of your sine function is always going to give you values between -1 and +1. So that means that we cannot take the sine of any, the sine of no angle, there is no angle whose sine would give me 1.18 because 1.18 is outside of the possible range of values that I could get. So that's why this is undefined. And another reason this is undefined, if we go back up here, this side length of 3 was actually too short to reach the segment AB down here. So you've actually had a situation where it was like this. It only came down like maybe this far, and it was just too short to reach it. So this is an example where you have no triangles, and whenever this occurs, you're going to be getting an error when you try to solve for your sine inverse. So that's how you know there's no triangles here. Okay, so example 2 had no triangles. In example 3, we're given angle A is 50 degrees, B equals 7, and A equals 8. So I'm just going to draw my triangle. Okay, angle A is 50 degrees. Side A is 8. Side B is 7. Okay, so let's see if we can find angle B. We're going to do 7 over sine B equals 8 over sine of 50. And we're going to cross multiply. So 7 times sine 50 equals 8 times sine B. Divide both sides by 8. Okay, and then we'll do the inverse. So I'm going to type it in first. So 7 times sine 50. Enter. Divide by 8. It's giving me 0.67028888. I'm going to do second sine to get my inverse function, second answer, and that gives me 42. I'm going to have to round, you're going to have to round these, but we're getting 42 degrees for angle B. Okay, so we'll do our two columns. We'll have A1, B1, C1, and then we'll be solving for side C, so little c1. And then we'll do A2, B2, C2, and then side C2. So angle A for both triangles is 50 degrees. We found B1 to be 42 degrees. Unit circle over here in quadrant 2 would give us, that's actually where I was when I stopped. So the supplement of 42 would give me 180 minus 42, 138 degrees. So in triangle 2, we have angle B is 138 degrees. And then we can find angle C. So going back to the first triangle, we can find angle C just by subtracting 180 minus 50 minus 42. So that gives me 88 degrees for angle C. And in triangle 2, what happens when we do the same step over here? We've got 180 degrees for the entire triangle. I'm going to subtract 50 degrees for angle A, subtract 138 degrees for angle B. Alright, and that's giving me an angle of -8 degrees. Now, I can have negative angles, but I'm not going to have a negative angle in a triangle. So because I'm getting a negative angle measurement, triangle 2 does not exist. So this is an example where we have just one triangle, and it has angles 50, 42, and 88. And then we can find side length C if we apply our law of sines again. So looking back at the original triangle, we'll do side C over sine of, what was our C? C was 88 degrees. And so since I've only got one triangle, I can draw it in here. Okay, so side length C divided by the sine of 88 equals, and then I can do side length 8 divided by sine of 50 degrees. And then I'm going to cross multiply. So C times sine 50 equals 8 times sine of 88 divided by sine of 50. Okay, and we'll see what that gives us for our side length for side C. So 8 times sine of 88, enter, and divide by sine of 50. It gives me 10.4. So side C had measurement 10.4. Okay, so those are the steps that you can go through for solving these side-side angle triangles. This is the ambiguous case, so we will be working on these some more together in class. All right, bye.